Good afternoon and welcome back. We have Maarten from Belgium now with us. Hi, Maarten. Welcome.
Hey, how are you?
Great. How are you?
Doing good. It's nice and sunny today. Almost summer after last weekend where we had snow, so really
Yes,
nice.
I just wanted to ask you that because I am located in Amsterdam and it's surprisingly sunny outside in the moment, and we had the snow just a week ago.
Yeah, exactly the same here.
Yeah, fantastic weather. So, Maarten, I see that you are working as a developer advocate. Could you tell me a little bit more about that position?
That's a complex one. So at JetBrains, a developer advocate essentially means doing things like we're doing here, just doing sessions, being present on social media, writing blog posts, doing screencasts, and all that. But there's also a big second part of the job, which is also coding on products. So during the demos, for example, I'll be using Writer to essentially show all the code and so on. And one of the things that I've been working on there is the Azure plugin in the IDE. So it's really a combination of the typical developer advocacy as well as being a developer in the product teams.
Well, I'm personally coming from the engineering background, but in the last year or two, I've been more towards the infrastructure as a code and started using functions. But I'm looking forward to see how and what you are actually doing with them. So
cool, thank you.
It's good. So you can start sharing your screen, and I will put it online.
Let's give that a try. All right.
Yes, just for you to be aware, the live is actually a bit late, so
yep,
everything looks fine. Maarten, the stage is yours.
All right, thank you very much. And thank you also everyone who is currently watching online or watching the recording afterwards. Really happy to be speaking here in Serbia, even though it's virtual this time, but would be nice to actually do that in real life at some point as well. So welcome from my side as well. And let's get started with some indexing and searching of NuGet.org with Azure Functions and Search. Now, before we start, there is actually one thing that I want to do. I also run the Azure user group here in Belgium, and there is no way that events like this can happen without sponsors. So I honestly want to say, even though I personally don't work with these sponsors, but thank you guys for chipping in because it really helps in making these community events worthwhile and essentially making them happy. With that out of the way, let's get started. So indexing and searching NuGet.org with Azure Functions and Search. It's a little bit difficult to do a show of hands while you're online, but there is the chat. So in the chat, if you have been using ReSharper or Writer before and know about this feature called Find This Type on NuGet.org, spread some love in the chat so I can see that, that people are watching. For those who haven't, I'll quickly explain what it is about. So in ReSharper and Writer, our tools for .NET developers, we have this feature called Find This Type on NuGet.org. So what it does is when you start typing an object name that you haven't referenced yet, but is available on NuGet, for example, what will happen is that ReSharper will give you this hint saying, look, I cannot find JSON convert in your code base yet, but what I can do is find this type on NuGet.org and then install that for you in your solution. So that is there. It searches for classes, namespaces, and essentially every type that is available in a package, a public type. And that feature came about in 2013 when we introduced ReSharper 9. The idea actually came about in 2013, so very early on in the NuGet times. I think we released in 2015. And it was built back then on, of course, having a plugin in ReSharper where we could show this quick fix and inspect that you don't have a package installed. So all of that, of course, but also a service. We have back then built a service that indexes packages from NuGet.org and also powers the search engine that is behind it. So if you search or if you have an object that you haven't referenced yet and you search for it, you will hit that service that has the index of all the packages on NuGet. Back then, we built this on Azure Cloud Services. If anyone has worked with those, They consisted of web and worker roles, where you could essentially deploy an ASP.NET application as a web application, and then have a worker role that could run the backend code. So we were using both. Our web role was running an API to actually do the search, and the worker role is doing the indexing based on whatever NuGet exposes in their OData feeds. Now you see this long URL on the slides there. Our indexer back then was making use of the OData feed that exists in NuGet, and the OData feed is essentially access to their database over HTTP. So if you open that one in your browser, and we switch to the browser, you will see this big chunk of XML data that comes in. But it's important to note in the URL, and I'll actually zoom in as well if I can. No, I can't. In the URL, you will see that we are running some sort of a query where we say we are interested in the ID, the version, and the normalized version of packages. And you will see in the response that we get back the version of a package, we get back a normalized version, we get back when the package was updated, and we also get a link to where we can actually download the package itself. Now, this OData feed, it's all XML, but it works really well because you can query, you can do a lot of interesting things like finding out all of the new packages since the last time you synchronized with NuGet and so on. So all of that is there. There's lots of information in there, and essentially if you want to download everything that is on NuGet.org, hit this NuGet OData endpoint, and at the end you will find a link to the next page of results. And if you keep going through all those pages, you will get all of the packages that are available on NuGet. Now, this has a little bit of an issue. NuGet over time has been growing a lot. Actually, the screenshot of this tweet is from 2018, November. Back then, NuGet was close to hitting 2 terabytes of packages. In 2015, it was only 250 gigabytes. I think the last time I checked, it's close to 4 terabytes. So NuGet is really growing a lot, and there's lots of new packages on there. Also, the OData feed that lives on NuGet.org is being deprecated. Actually, it should be deprecated already, but it's still about for older NuGet clients and so on, so you can still use it. But it is sort of going away. And the reason for that is, first of all, it's getting slower and slower because the OData feed is really HTTP over database. Which makes it nice to use, but it also gets slow after some queries, or if you want to fetch page 20,000, it will get slower as well. So the OData feeds and the growing size of NuGet.org was sort of getting in our way of making this indexer work properly. So let's talk a little bit about what you can do on the server side with NuGet. And I know I promised to talk about indexing with Azure Functions, but we need to know this before we can actually jump into that part as well. So if you look at the NuGet server side, there has been that OData protocol, which is essentially the version 2 protocol of NuGet.org. But there is now also a v3 protocol. Essentially since 2015, I believe, there's been a v3 protocol that is JSON-based. Instead of just doing essentially HTTP over a SQL database that they have, this v3 protocol is really a collection of resources that give you different APIs depending on what you want to do. So for example, on NuGet.org, you will find in that index.json v3 protocol document, you will find a resource provider that gives you access to the NuGet.org catalog. The catalog is really an event-only or an append-only event log of all of the packages that have been added to NuGet.org. You will find registrations where you can find information about which packages are where, who are the authors, what tags do they have, which frameworks do they support, things like that. There's also the flat container, which is being used during NuGet package restore, because essentially you know which packages you want to retrieve. So you can essentially hit a URL by convention, and that's the flat container. It gives you the package binary. There's details about statistics. There's something to figure out what abused URL should be shown in the Visual Studio or Rider UI. So lots of different resources in this protocol, depending on what you want to do with it. Now, for our use case of indexing NuGet.org, the catalog is actually really interesting. Because it's an append-only stream of all of the mutations that happen on NuGet.org, it gives you access to all updates, adds or updates of packages, and deletes that happened chronologically over the history of NuGet.org. So if you, just for fun, want to restore NuGet to the time it was back in 2016, you can use the catalog, start from the beginning and run just until 1st of January 2016 and get all of the packages that have been added and deleted up till that time. This is also interesting because if we run our indexer every day or every hour or something like that, it's very easy for us to store a timestamp and just start reading the catalog from that specific timestamp and then get all of that information from this catalog. The structure of the catalog is so that you have a root. It gives you information about all of the pages that are available in the catalog. And then every page has leaves of data, and those leaves actually contain the data for specific packages. I'll quickly show you how that works so that you get an idea of what it looks like. So if you go to api.nuget.org/v3indexjson, you will see the catalog, or sorry, the index document for the v3 API on NuGet. You will find that if you want to do searches on NuGet, there's a type called search service, and you can use this one to do searches. There's two of those, so in case this one goes down, there's still this that you can use, and you can do some load balancing and things like that. There's an auto-completion endpoint, so the autocomplete you get while typing in the NuGet tool window will give you information about which packages are available. All of that is there. And essentially, depending on what you want to do, you will find one of those types and then find the URL for that to do something. So if you want to figure out where to publish packages, also that URL is there. The one we are interested in is somewhere at the bottom, I think. Should probably search for it. Search is probably going to be easier. Let's search for catalog. And you will find that there's a catalog at this URL. So we go there, that's the root of the catalog, and the root of the catalog has links to various commits to the catalog. So you will see that there's multiple items that describe a catalog page. They have some identifier, and they also have a commit timestamp. So this is where that cursor-based approach comes in. Because you have this timestamp, you can quickly scan this document, find the timestamp that is closest to where you want to start iterating the catalog, and then start from there and go with it. Just for fun, let's open one of those catalog pages to see what is on there. So in those catalog pages, you will again see that this is a catalog page. Again, commit timestamp, and you will also find the items that were committed to the read-only or to the append-only catalog at this time. So you will find that there have been package details that have been added or updated for a package called retyped.node unit with this version. It was committed at this time. And if you want more information about this package, you can find it here. And if we go there, you will see again that these are package details. You will find authors, you will find copyright information, description of the package, icon URL. So everything you want to know about this package is somewhere in there. Now, obviously, it's not so nice to actually have to manually follow all of these URLs. An interesting side note here is that the NuGet team itself makes use of this catalog to build their search index and other things as well. And if you go to their GitHub repo, you will find a package called nuget.protocol.catalog, which I have in the IDE here. And that gives you access to working with that catalog. Now, I made a few minor changes for our use case, which is why I'm not using the package that they published on NuGet, but essentially this project is what is available on GitHub. If you start using that, you can actually start writing something to fetch packages from nuget.org. So what you will need is an HTTP client, because obviously you are going to make requests to the internet. You will need a cursor. In this case, I'm just storing the current timestamp that I'm processing in this catalog in memory. So I'm using an in-memory cursor. And then I will make use of a batch catalog processor. What this one will do is make use of our HTTP client and connect to the nuget.org catalog. And whenever a package is added, it will execute this code. Whenever a package is deleted, it will execute this code. So this batch catalog processor class is doing all of the stuff that I've been doing manually in the browser before for us in code. And essentially everything you have to do is define where you want to start with this cursor. and then responds to packages being added and packages being deleted. So in our cursor, what I'm going to do is I'm going to set the timestamp to now minus, let's assume people publish packages to NuGet.org on Saturdays. So I'm going to fetch all packages from the last 1 hour on NuGet.org. If I run this, you will see that we'll have to wait a little bit because the catalog processor obviously has to fetch all of the information on where to find the catalog, which pages to access, and so on. And at some point, you will see on the console that actually a lot of packages seem to be published on a Saturday. So if you came here for useful information, 11:07 on a Saturday, octopus.NET CLI version 7.4 has been published. You have seen this live. It's really just been published just a while ago. All right. Why am I showing you this? Again, because we will need it to index NuGet.org, and I wanted to quickly show you how you can access the catalog and how the catalog works under the hoods. So keep in mind, there's a cursor to know where to start in the catalog, and a catalog processor that can respond to a package added and a package deleted event. With that out of the way, let's talk about our find this type on NuGet.org in ReSharper and Writer. So OData is going away, apparently. There's also lots of information on NuGet.org, and we are currently looking at migrating away from the OData protocol to using the v3 catalog. Actually, that is deployed and that is live. The only downside is that the v3 version does not yet have download count information for NuGet packages in there. So our current setup is making use of the v3 protocol, but also still uses OData to periodically get an idea about how many people are downloading certain packages, because that obviously helps in ranking packages when you search for them. Now, when we started exploring migrating to the version 3 protocol, we decided to build a new version from scratch, or maybe update the existing one. And updating the existing one is what is currently live. We also made the exercise of building an Azure Functions-based version, and that is the remainder of this talk. So let's dive in. So building a new version. If you start thinking about what we need in terms of functionality in this solution, you will find that we will need 3 main things. We will need to watch the NuGet.org catalog for any change that comes in. For every change that comes in, we will have to download the binary from NuGet.org, scan all of the assemblies that are in there, and somewhere in a database or wherever, store the relation between package ID and version and certain namespaces and types that can be used in this project. And of course, since we have been shipping this solution since ReSharper 9, we want to have an API that is compatible with all ReSharper and Writer versions since then. So this means that, we had to do a little bit of reverse engineering even to figure out what the API looked like, because it was documented in code, but we didn't really have an open API spec or something like that. But doing all these things should be doable with a periodic check. Checking whether there are catalog changes can be done every 5 minutes, every hour, even every day. We could run a timer, check if there's new changes, and if there are changes, push those changes into a queue somewhere. Based on that queue, we can pick up work. Every package will be an item in a queue, and then scan the assemblies and store them somewhere. And then for the API, we can use pretty much anything that is just always up and can scale based on how many users are actually making use of this specific feature. It does sound a little bit like functions, because in functions, we could have a function that watches our catalog and reads from that catalog on NuGet.org. We could have a command in a queue that serves to download a package and one to index a package. Both of those queues can be read by yet another function that will then execute that specific workload. And having our web API hosted somewhere can actually also be an Azure function, because those can scale. We can even scale down to 0 and just incur a little bit of startup time. But it's really inexpensive to host a very simple API on Azure Functions there as well. So this story definitely sounds like something that we could do with Azure Functions. So let's get started with the first part, collecting data from our catalog in Azure Functions. So let's look at code here. And in our NuGet type search project here, which is a project that contains all of the logic, what I'm going to do is create a new class. I'm going to create a timer trigger because I want to create a timer that will check every 5 minutes whether there's information available in the catalog or not. So let's call this one demo timer trigger maybe, because I will dispose it afterwards. What our timer trigger is going to do is it's going to run, let's say, every 5 minutes, maybe every 15 minutes is fine as well. And by the way, if you see one of those IDE errors, I'm using a nightly version of Writer, so this may happen. What our timer is going to do is then run every 15 minutes, and we are going to write some logic in there. Now, writing that logic is not super interesting, so I'm just going to use a template here and make sure that I include all of the classes that are there. And I'm going to call this one timer. And then we will go through. So what I've done here is essentially I replicated all of the codes that I had in my console application previously. Again, I will make use of an HTTP client. I will make use of a catalog processor that will then print something to the log whenever a package is added and print something to the log whenever a package is deleted. Of course, in our final solution, this will be adding a command to a queue somewhere that we can process. But just for demo purposes, assume that this is the first step in getting information from our catalog. Timer triggers in Azure Functions are quite nice because the binding that you have gives you some information on when this task has last run. So there's no need for us to store a cursor somewhere in storage. What we can do is simply look at our timer info, get our last scheduled status, and if we want to start processing packages from NuGet, we simply start from the time that our timer last run. Which makes it easy because Azure will schedule things for us and we get information on when it was last run, so we can start in our catalog reading from there. Now, obviously, if it's the first time that we will run, there will be no information. And again, for demo purposes, I will make use of the last 2 hours of data on NuGet to start with. So this function, we can run that one, and let's see what comes up. I'm also going to show you a little quick side note here. So we have a timer trigger, and it will run every 15 minutes. And since this talk is going to be not much longer than 15 minutes, it might take a while before this will actually run. So we want to run this at some point. What I see a lot of developers do is before they run this application, they do something like this where they want to run this every single minute. Very often, these changes go to production and that's not ideal. So what you can do is you can trigger timer trigger functions from an HTTP prompt. So if you have an HTTP function, obviously you can make use of that HTTP function as well. But if you have a timer trigger, there's a specific endpoint that you can use to actually invoke a timer trigger on demand. So what I'm going to do is post to this endpoint. There we go. We got a 202 accepted, which means that right now our timer should be running. So we get some information and our timer says that the UTC time presented is not correct. Interesting. So my trigger is failing. But anyway, I hope you get the idea that this will do essentially the same that we had in our console application previously, fetching data from NuGet every 15 minutes and making use of this trigger binding to get all of that information from NuGet there. All right. Cool. Now, our function is doing a little bit too much work. There's a couple of functions best practices. Actually, Paul D. Johnston, who is one of the main authors of Lambdas on AWS, he's been doing a series of tweets and blog posts and so on about best practices in building serverless applications. And some of the things he mentions is that every function should do just one thing. Doing just one thing makes it easier for a function to scale and easier to find where an error is occurring and to do error handling and so on. Also, by doing this, by making sure that your function is only doing one thing or a small group of things, you will have to use the concept of messages and queues and message passing and so on, which means that by default, you are automatically decoupling functions from one another because you're communicating over messages. And this will also help you scale and avoid coupling. And it's easy to have another subscription from a new function to extend your application. So there's multiple benefits to starting with every function doing just one thing and then going from there. Now, to do only one thing, we would have to update our code quite a bit. Right now, we had a timer trigger that would trigger our function and then fetches data from the catalog and then adds data to our queue. That's way too much work. It can be optimized a little bit. Azure Function actually gives you the option to do just one thing. Getting data or retrieving data from somewhere. Of course, you can do that in code, but ideally, you will make use of one of the standard bindings to give you inputs so that all your function has to do is run some logic. In Azure Functions, there's a number of default bindings that will run. There's this timer trigger that will essentially run a function at a specific time. There's an HTTP trigger that will handle an HTTP request that comes in and then invoke your function with the data that is coming in. There's a queue trigger that will trigger whenever a message comes into a queue, etc., etc. So a number of default triggers that are available in functions. You may also notice that there's different types of bindings that you can use in functions. There's triggers, and the word sort of speaks for itself. They trigger your function. They will run and invoke the function that you have. But there's also a couple of input and output bindings that you can use. Again, I mentioned your function ideally should be doing just one thing. So instead of writing data to a blob manually, you can make use of a blob output binding to get a stream that the Azure Functions runtime will prepare for you and link to a blob storage account and things like that. And all of the logic that your function will have to execute is essentially writing to that stream. So you don't have to take into account retries and things like that. Your function can concentrate on just doing one thing. These bindings are there by default. There's a big number of them, and obviously they all make use of services that are available in Azure, but it's also possible to build your own bindings. I have seen online a SQL Server binding. What that binding will do is essentially you pass in a query to the binding. The function's runtime will run that query periodically against the database, and whenever it finds new data, it will invoke your function. I have seen a Dropbox binding out there as well, where if you generate a PDF, for example, as part of a function, you can simply write to that Dropbox binding, and that binding will take care of actually storing the file somewhere on Dropbox. For our situation, I would really love to have a NuGet catalog trigger binding so that I don't have to manually go and check whatever is available on NuGet.org. I just want the function's runtime to call my function whenever there's a new package on NuGet. Unfortunately, such trigger binding does not exist. So I guess you can already imagine that that's the next thing we're going to do in this talk. We are going to build our own trigger binding. There's this asterisk on the slide as well. You can build your own input and output bindings, and they will typically work. You can also build your own trigger bindings, but these are not officially supported. It is possible, but there's a couple of side notes there. One being that you cannot use the consumption plan to have your custom trigger run. You will have to have a reserved instance that will run your trigger continuously before it actually works. So keep in mind, triggers are supported. And for us, I mean, our service is still running. They work, but every once in a while, you will need to restart and go in there and make sure that things are running. But of course, that's where monitoring comes into play, right? Cool. With that, let's change our timer trigger function. Let's just remove it and build a custom trigger binding. So let's go back to the IDE. Close this one. I'm also going to remove our demo trigger because we won't be needing that one. And let's look at a better approach of getting data from Azure Functions. So this function that I have here is essentially going to do our first step. It is called enqueuer, because this one will listen for changes coming from the NuGet catalog, and it will output messages to a queue called the indexing queue so that we can pick up whatever work comes in and we can start working with that thing. So instead of doing all of those things manually, this function, what it will do I'll make a little bit more room here to make it a bit more readable in this resolution. What this function will do is it will be triggered by new packages on NuGet. Whenever a new package is available on NuGet, we get a package operation object into our function. The package operation object, by the way, has an ID, version, all of the information that is available in the catalog. When we get that package operation, we can run our logic, and somewhere in our function, at some point, we want to write into a queue collector so that we can store a command in a queue that will serve to index operations. So a trigger binding that gives us input as well, and an output binding that is a queue binding that will handle writing a message to a queue for us. Our function now is much simpler. So instead of doing all of this checking of our NuGet catalog manually, what this one can do is simply log the fact that we are adding a NuGet package and then forward the operation into a queue for further processing in the indexer. Now I know there's going to be some Q&A at the end of the session. One thing I want to mention, and you may have this question right now seeing this code, is if you have this NuGet catalog trigger, why are you still writing it to a queue before it will actually be picked up by an indexing process? Good question, if I can say so myself. The reason for that is that since our NuGet catalog uses a cursor to traverse all of the packages that are in there, we can actually only have one of those, because if we have multiple of those running, we will have multiple operations firing, maybe having duplicate packages being processed and so on. So what we want to do is have one single function running that gets data from the catalog and then forwards items into a queue so that from that queue, we can fan out to multiple indexing processes. So that's the reason why we are essentially just triggering on a NuGet catalog item and then forwarding into a queue. All right, with that out of the way, let's have a look at how you can build your own NuGet catalog trigger binding. So if you dive into the source code of any binding, you will find that a binding is very much a very simple .NET attribute. And that attribute will have some properties that you can use to configure your custom bindings. So for our NuGet catalog trigger, I added a service index URL property that you can configure. If you want to run this against a NuGet staging environment, for example, you can make use of a different service index URL and pass that on into that binding attribute that you have in code. Same thing with using previous hours. I added this one for debugging purposes. If I say I only want to index the latest 1 hour on the NuGet.org catalog, I can make use of that one as well. More interesting is that I will have to store my current timestamp in the cursor somewhere. So what I am passing in is a connection string, which will come from app settings. And I will define where I will store my current cursor value so that next time my binding runs, I can actually make use of the latest timestamp to traverse our catalog. I will go a little bit into those later on, but just to give you an idea about the configuration that our catalog trigger attribute will need. Now, obviously, there's not a lot of code in here. This is really just a way to put an attribute on a function and configure the attribute a little bit. So where does the actual binding start to work? Well, if you have your NuGet catalog trigger attribute, you can annotate it with a binding attribute. And this is something in the functions runtime that will recognize this as being a binding. Now, obviously, that also is not yet enough. In your project or in your custom binding project, if you are using a different project for that, you will have to also write a startup class that will register itself with Azure Web Jobs, which is the underlying runtime for Azure Functions. And in there, you will have to say that you are extending the functions runtime with a NuGet catalog trigger extension config provider. I know that's a really long class, and it's almost like a Java application here. But there's a little bit of configuration by convention involved as well. So if you have a NuGet catalog trigger attribute, it's best to use long names that represent whatever you are building. This extension is really what registers your custom binding with the Azure Functions runtime. So let's have a look at that one. What this one will do is it will implement an iExtension config provider. and again have the annotation saying I'm an extension and I have NuGet catalog binding and whatever comes next. What this one will do is handle the actual registration with the Azure Functions runtime, because you can have trigger bindings, you can have input bindings and output bindings. There's some different ways on how you would register those with the runtime. So here, what we are saying is runtime, if you encounter a NuGet catalog trigger attribute, please assume that is a binding for a NuGet catalog trigger attribute binding provider. Again, long class name, but essentially we are telling the runtime to, that when it encounters this, when it encounters our custom binding attributes, bind it to whatever class you have there. Let's look at that one, because that's the one that will run the actual logic. What this one will do is it will provide a trigger binding provider to the runtime. What it will require is a name resolver, an account provider, and a logger factory. Reason for those is obviously we want to be able to log something to the output as well to get an idea on what is happening at runtime. We will also need a storage account provider, because I mentioned we want to store a cursor somewhere in blob storage. We will store that using the storage account provider. And we'll need a name resolver to essentially be able to handle naming of the files and so on that we are writing. What else this one does is not a lot. It essentially checks whether, when we try to create a trigger binding, it checks whether we are actually working with that NuGet catalog trigger attribute. If not, fine, just give up. If we are, we can check whether it's really intended for us, do some setup, for example, on figuring out where we want to store that cursor to traverse the catalog and so on, create that container if it doesn't exist, get a blob reference so we can write to it, and then give the runtime an actual NuGet catalog trigger binding. Lots of boilerplate code, but essentially what we are doing here is telling the runtime that if you encounter our custom attributes, do some configuration and then return a NuGet catalog trigger binding. This binding is where our binding implementation really starts. What it does is it has a method that is create listener async. This one will be called by the Azure Functions runtime to create a catalog listener. The listener is going to be the actual object that fetches data from the catalog and can be used to tell the runtime that, hey, there's new data, please run our function. I'll cover that one in a bit because there's two more aspects that are important in this trigger binding. You will find that there's a property, actually two. There's a function called bind async and a property called binding data contract. If you are writing custom bindings, you don't have to implement those, but it is recommended to do so. Because what you are doing here is essentially telling the functions runtime what the contract of the data is that this binding will provide to the runtime. If you do this properly, you will be able to write a custom binding in .NET, even if you have PowerShell-based or JavaScript or PHP-based functions running. They can still get data from our custom binding that we have here in C#, which is quite interesting. So by defining this data, other runtimes on the functions runtime or other languages on the functions runtime can actually know what data to expect and what they can work with. So essentially, we're providing a map that says, here's the raw JSON object, but by the way, there's going to be an ID property of type string. There's going to be an action, which is going to be added or deleted, which is also going to be a type string, etc., etc. So again, these two are not really required, but it's good practice to add them because they define what the data format looks like. But if you're not interested in writing those, essentially your binding will be an implementation of that create listener function. So not that much boilerplate code, just as much as you want it to be. Our listener is where the actual logic is happening. What our listener is doing is making use of our service index URL, our cursor blob, etc., to, at some point, create that catalog processor that we had previously in our timer as well, get data from our catalog, make use of that cloud-based blob cursor that we have, and so on. And based on that, it will invoke package added, or package deleted. When package added is run, we will call into the function's runtime and say, look, we are triggering our function, and here's the data to provide to our function. And you will see that we will generate a package operation that will then be passed into our function. So by writing all of this code, and I know this kind of sounds horrible, but writing all of this code makes it possible to have a very, very clean function where you can say, okay, I want to trigger on NuGet catalog and get a package operation that is coming in there. Whew, that's a big one. Now, if we run this, our trigger binding will periodically check everything and will just invoke our function so that we can run it and work with that one. All right, with that out of the way, and I know it's a lot of code, and I have a quick note at the end talking about this, so let's keep it for then. But just keep in mind that you can build your own trigger bindings with some caveats. All right, we're making progress. We have our catalog watcher function, and we can now continue with some additional functions. I'll start with our download package function because that's going to be a really, really easy one. Our enqueuing function, that's actually this one that will be run. What it is doing is it is going to be triggered based on our custom NuGet catalog trigger, but it will forward this message into 3 storage queues. It will tell a queue that there's data to be indexed. It will tell that there's data to be downloaded and something to fetch some additional metadata for some statistics and so on. Again, the function itself is really easy. We get into our function a package operation, and we forward it to certain queues. This download queue will be processed by our download to storage function, which is then going to do the actual download. So this one makes use of a queue trigger binding. So it will trigger whenever there's new data to be processed. And when there's new data, we get that package operation from our queue. We can fan out based on this. And what this one will do is download the package. Actually, that code is here. So it will download the package from its URL and then upload it to the package blob, sorry. That package blob is provided by a blob output binding. So again, functions doing just one thing. What is happening here is we're telling the runtime that we want to work with a blob with this specific name, and we want to consume it as a package blob. So no need for us to use retry mechanisms and things like that. Storage queues or the Azure function will give us an operation coming from a queue, and it will also give us a reference to working with a blob that is there. One thing to note, in our custom binding implementation, you may have seen that we had this iname provider instance that we could work with. The blob binding is actually making use of that iname provider, and it will be able to generate a blob file name based on certain placeholders that you can put in there. And those placeholders will be populated with whatever is coming in from your current trigger binding. So our package operation class has an ID property and a version normalized property. So what this blob binding will do is generate a file name that is actually the actual file name for the blob that we want to write. So if you write a custom binding, you can do something similar here, making use of that iname provider to resolve those placeholders and see whatever is in there. But again, very simple function, this one, just a queue trigger that will trigger and write data into a blob. Now, I see that I will have to speed up a little bit because time is precious and time is pressing. So let's start with indexing as well. Indexing, I have a longer version, by the way, of this talk on my blog, and I will show you the URL later on, where you can find more information about the technical side or the technical side of breaking up the NuGet package and figuring out what types are in there. But suffice to say that our indexing process is going to download the package, use a way to reflect on the assemblies that are in the NuGet package, and then extract all of the public types so that we can know what to search for later on in our API. We will have to store that relationship between package ID version and the public types and namespaces. So we can use search, we can use a database, we could use Redis. For us, since we're building a search engine, search seemed like a good option here. So we decided to make use of Azure Search. Azure Search, if you don't know this one, is search as a service. It gives you an API that you can use to define an index that will hold documents. And documents is like a record in a database that has fields, which is like columns in a database. So your index will hold all of the documents or records and fields, and you can search through all of those fields that are in there. Now, fields are a little bit specific in that they can be searchable, they can be facetable, so you can do grouping and so on. In an online shop, for example, you can typically group by manufacturer or something like that. That's a facet in search. Fields can also be filterable, so you can filter on just one specific manufacturer, for example. They can be sortable, and more of note, they can also be retrievable, but they are not by default. This structure is really defined. The index is optimized for serving this structure. So think about what you want to search, what data you want to be able to retrieve from the index as well. And I'll quickly show you how we can do this. So let's switch to code again and go into our actual package indexer. We make that one smaller. So our package indexer, what it is going to do is it's going to run a function, again, triggered by a message on our indexing queue, and then write data to a blob, but also do something with Azure Search. I'll cover the Azure Search part of this function. So for search, we have to create a client to our search service in Azure, an index as well. And when our indexer starts, and I'm doing this in a static constructor here, we also want to be able to build our index so that it's up to date and we can actually start working with it. You will see that fields are built for a package document type. I mentioned that you have documents in search and documents have fields. Well, this package document type is the actual definition of what we want to store. So you will see that we have this package documents, and our package documents will have properties that represent everything that is in there. So we will store the identifier, the package ID, package version in different formats, package title, package summary, authors, and all of that information is going to go into the search index. Now, for our API, we don't want to search on everything. Since you will be searching for unknown types in your code in the API, what we want to search on is going to be package ID and version, because that's always useful to be able to search for those, as well as where are my type names? So my type names are also going to be searchable, because that's what we will be searching for in our use case. What is important to note here is that we have all of these other properties like title, summary, authors, and so on as well. Why are we storing them in the index, but making them retrievable instead of indexable or searchable? The reason for that is some fields can be searched through, other fields can be just metadata that you want to show in the UI. So when we have a package document that matches our search, what we want to be able to do is look at the title and summary and so on of this package, so we can actually make use of that. Right, back to the function. Our indexer will make use of that index, and whenever a package is added, we run this add packages async, and we download the package, we do some logic with that, and at the end of this thing, we will essentially return, it's going to be somewhere in there, I know it's a lot of codes, we are going to return index actions that will be updates to our documents that we have in search. If you're interested in the technical side of cracking open the assembly and seeing what is in there, I will give you the link to my blog, but otherwise, it's safe to assume we do something and then we push data into Azure Search. Right. Again, our function should do one thing well. So I didn't really show this one because it's only 45 minutes this session. If you want the full code of this with a better example where I also created a search output binding, feel free to go there, because an output binding, again, will make it easier for our function to do just one thing, which is downloading a package and cracking open the assembly, as opposed to also handling the fact that the index should be existing, retry logic on adding documents into our search engine and things like that. So again, do one thing well, maybe build an output binding to store data in Azure Search. And I actually did that. And again, you can find it on my blog posts. Right, almost there. The only thing we still have to do is build an API to fetch data in ReSharper and Writer. So let's quickly look at that one as well. It's not really special in that we had to rebuild our API that we had for ReSharper, but we are running it as an HTTP trigger function in Azure. So we have a function that is find namespace and a function that is find type. They will essentially do the same thing. The only thing is that one searches for a type, the other one searches for a namespace. So that's why we created the two of them in one class. And we are just passing everything into run internal async with two different types of parameter. What we're doing in there is building our search query text. And you may have noticed that in our search document, the type information, all of the different public types are stored in a set of strings. An interesting thing is that if you search for type names, they are going to be namespace.subnamespace.typename. So our search text can also be type names and start with a dot. Since we are searching for a type name, we want to search for dot whatever follows. If we are searching for the namespace, we search for just a namespace followed by a dot because that's going to be the first part of our search. Next thing we do is run the actual search. And again, it's some logic to make sure that we can actually get packages that are listed and whether we want to do pre-release packages, we do some scoring and so on. And at the end, we return packages on our API. I'll show you that it works. So first of all, in the browser, if you go to nuget-type-search.azurewebsites.net, you can search for example, JSON convert or JObject, and you will see that our search now returns that JObject is in newtonsoft.json and gives me back all of the assemblies in there, all of the types that are in there, etc. And in ReSharper, what we can now do is write some code and say var foo equals new JObject. You will see that that type is not yet referenced. We can do an Alt-Enter, find this type on nuget.org. We are hitting our custom API. We get back all of that information that we stored, so download counts, package title, and so on. And from here, we can add it into our project and we can get working. So essentially, using functions, we were able to replace this existing feature in ReSharper. So the only thing we have to do now is actually make use of it. All right, 1 minute left to make a conclusion. So in summary, we're done. We have a functions pipeline to collect data from NuGet.org. We're downloading binaries, we are indexing binaries, and we have built a custom trigger binding to read the catalog, and we have built a custom output binding to store data in Azure Search. All of our functions can scale and fail independently. Which is actually quite interesting. Our NuGet.org catalog watcher has to run on a reserved instance because, again, it's a custom trigger binding and it has to be online 24/7. But all of the other functions are just consumption-based. So if nobody publishes packages to NuGet, we don't have the indexer running. Whenever a new package shows up, function spins up an indexer. When nobody's searching for packages, we have no API running. If someone is searching for packages, again, we can spin up a new functions instance and handle those. Really nice is that because of that, we can indeed scale them independently, but we can also fail them independently. So if for some reason the indexer stops working, we still have the API running to search packages. The information will be outdated a little bit, but the indexer can fail independently from everything else in there. So again, doing just one thing in every function means that you can scale, but also fail independently. For people who like numbers, we did a full index back in May 2019, and that took us 12 hours on 2 B1 instances in Azure, which is not a very powerful machine. 12 hours may seem long, but for this type of information, it's just fine. And our current indexer, or at least our previous indexer, took us 2 weeks to index the entirety of NuGet. So 12 hours is definitely an improvement on very, very cheap cloud hardware. We also found that the NuGet.org homepage, back then at least, was lying to us because there were 2.1 million packages in the index back then, whereas NuGet only said 1.7 million. There were about 8,400 of those catalog pages that we had to process. Every package was in there twice, which is kind of nice because NuGet at some point started signing all of the packages in NuGet. So they did a republish of essentially every package that is in there. So we were able to actually see that at some point there was a huge spike in new packages because they were all updated. Last time I checked in January this year, there were 3.5 million packages in NuGet, good for close to 4 terabytes of data, which is quite interesting. A few closing thoughts. If you deploy this to Azure Functions, I would deploy all of these in separate function apps for cost reasons, but also for scaling reasons. So have that trigger binding in a reserved instance, whereas everything else can be on demand and just respond to whatever data is there. A quick note about bindings as well. I found them really, really nice to work with because your functions can be really clean and short and do just one thing. If you want to make things portable to other clouds, to other functions, frameworks, and so on, if that matters to you, I would probably not look into them. But if you have anything else where you have input and output, you can make use of that and actually make use of that programming model because it's really nice. There's a bit of boilerplate code involved, but it's still really nice to work with. So with that, 2 minutes over time, I think. Full blog post with the full implementation is on my blog. And yeah, thank you for joining us today.
Yes, hi, Maarten. Thank you for a great presentation. As you mentioned, the viewers can find the information in your blog post that will also be shared on our website within your profile, so they can reach you out on Twitter or on LinkedIn if they have more questions. And unfortunately, I haven't seen any questions coming in the chat, so I'm guessing that the developers are sleeping on a Saturday morning still. Well, this seems like a very complex project that you did, and yeah, great things that you achieved with functions.
It was fun to build, and again, the full story is there. So if you want some more, there's some things about sharing HTTP clients and so on. So there's lots of small nuances. And again, I would say everyone, if you're interested in those, the blog post is there.
Yeah. Okay. Great. So just a question. I'm just guessing. Did you have any specific issues with accessing APIs from the NuGet side, or?
Again, the only API that we're actually missing is download counts, which would be really nice to have to be able to order packages in the index based on how often they are used. But since the OData feed is also still there, there's still the option to get the data from there.
Yeah. Okay.
But other than that, everything that they have in NuGet.org is pretty much public.
Okay. Tell me, do you manually now initiate the functions from time to time, or you have a trigger on a new package? I didn't catch that.
Yeah, so the catalog binding runs continuously. So whenever a package comes up on NuGet, typically within 2 or 3 minutes, we have it in our index there, which is quite nice. So that runs on a reserved instance and just continuously. We have to restart it every couple of times, maybe 4 or 5 times a year. So while it's not officially supported, it seems to hold well. But we have application insights where we can see if a queue remains empty for a long, long time. We know nothing is being added into those queues, so we probably know that our custom binding is no longer running.
Okay. Great. Once again, thank you very much for a great presentation. And
happy to do so.
I'm sure that I'm going to share this with the internal developer teams. I think they will be able to use it pretty much.
Nice.
Okay.
All right. Thank you.
Enjoy your day and hope to see you next time also. Some new fun things. Bye.